I have a second channel, Cube Comp MTDX. Everybody, I'm going to take a moment to talk about lithium-ion battery safety. About 3 years ago, I got into harvesting 18650 lithium-ion battery cells out of laptop batteries as a more reliable means of powering my torches and my flashlights. I've always had several high-power LED flashlights like this here for around the house, and also for my road bike's headlight, because I do ride at night quite a lot. And I was getting sick and tired of my nickel-metal hydride cells just randomly dying on me. And of course, lithium-ion batteries are a much more reliable source of power, and they also hold a lot more capacity than your typical nickel-metal hydride cells do. So, if you look on YouTube, you'll see lots of videos of people harvesting cells from laptop batteries, like this here. This is your typical laptop battery. This is a, I believe, a 6-cell pack. And inside this, you have 18650s. I'm going to pull this off, so you can see what they look like. So you have, for example, this is a 6-cell battery, like that. That's what I'm going to mention, that if you're not very familiar with these cells, it's important that you are familiar with them before you start to crack open laptop batteries and pull these things out. Because let's face it, when they're in a laptop battery pack like this, they're all hooked up to a circuit board right here that handles charging, monitoring when discharging, as well as cell balancing. It ensures that these cells do not get below a certain voltage, and it ensures that if they do get below a certain voltage, that the pack will refuse to operate. Also, when these are charging, it helps ensure that they do not get above a certain voltage, which is 4.2 volts for most cells. And also, the cell monitors the temperature of the batteries to make sure they're not getting too hot, and also to refuse to charge when they're getting, if, let's say, they're too cold. Because lithium-ion cells like these here cannot be charged when it's below 0 degrees Celsius or 32 degrees Fahrenheit, or in other words, freezing. You can run them, you can use them to power something below that temperature, but you can't charge them below that temperature. So, anyways, there's a lot of videos on YouTube of people cracking into these things. I just want to mention that you don't want to go at it too quickly. You gotta use caution with these things, because these cells, they can be dangerous if you're not careful what you're doing. When you harvest these cells out of a pack like this and you're using them in a bare form, you no longer have that protection circuit. These cells are now relying on you as a user to make sure that you're not over discharging them and overcharging them and stuff like that. One thing I recommend is that you invest in a good quality charger, such as the Opus BT-C3400. This is a very, very nice charger. It does a good job of monitoring cells. When charging, it tells you how much capacity you're putting into your cells, how much you can pull out, because if I cycle through the different modes, you have your regular charge. Let me just select all the slots here, and there's nothing in. Discharge refresh. I think this is for nickel-metal hydride. Yes, this thing can actually do nickel-metal hydride cells as well. It has a charge test function, quick test, which checks the internal resistance of the cells in milliohms, and of course we're back to charge. This thing can charge up to 1 amp, and also it can charge either your regular 4.2 volt cells, but also 4.35 volt cells when you do this modification. There's a little switch inside there that you have to get access to switch it from 4.2 to 4.35 volt mode. And I'm going to talk about that a little bit as well. So, when you harvest these things, you have to be aware of what they're designed for. These are laptop battery cells. Okay, there's a lot of videos out there on YouTube, and there's also a lot of forum posts on certain websites of saying, hey, if you're a vape user and you want to find cells for cheap or free, just crack them your laptop and you'll have plenty of 18650s for your mod. That's not exactly a good thing to do. Now, it's because these cells, these are what's called high-powered low-discharge cells. These typically have a lithium-cobalt chemistry in them, and they're designed to hold a higher capacity to power electronic devices like laptops or cameras and things like that. They're not designed to be able to put out a lot of current at once. So if you're looking for cells of that nature, you'd want to look at if you want to harvest cells for stuff like that. I'd say look into harvesting from power tool packs. So the cells that you'll find in power tool packs like this are vastly different than what you'll find in laptop batteries. So I have to keep that in mind. So my cells, I use them to, number one, run my flashlights. Number two, run my video cameras. So as mentioned earlier in the video, when I started harvesting these things, my original intent was to use them to power my flashlights like this here. These flashlights take one 18650 cell. You can either power them with one 18650 using this included spacer tube, or you can power them with 3 AAAs using this little adapter piece, and it goes down inside like that. Essentially, one 18650 can replace 3 AAA cells in series, because the nominal voltage of a rechargeable nickel metal hydride cell is 1.2 volts per cell for a total of 3.6, and the nominal voltage of 18650 is 3.6 volts or 3.7 volts. It really depends. It's kind of a back forth number. So 3.7 volts, it replaces 3 AAA or AA cells, or nickel metal hydride cells in series. So pop that back in there like that. Yeah, I got the spacer in there. So there's some things you got to keep in mind when you're handling these cells. I apologize if I cover something twice, but maybe it's not such a bad idea if I do cover it twice if you're new to this. So you may see this little this little cell here has some tape around the front of it. The reason why that's there is because this cell has a small nick in the cell wrapping. So right over here are 2 bare 18650 lithium-ion cells, and they are completely discharged. So that's why these were bad cells out of a laptop battery. They had practically millivolts on them. They had like 0.1 or 0.2 volts on them. So I went ahead and stripped off the cell wrapping and also the insulator disc off the top so that we could see exactly what these cells look like. So this is actually naked form of this exact cell here, because it's made by the same manufacturer. This is a generic cell out of China, and that's what you actually have down inside there. So it's important to note that everything right here is positive, whereas this right here is negative. The entire side, the lip at the top and the bottom of this cell is negative, and this part here is positive, which is why these cells have wrapping around them and also a plastic or like a Teflon insulator disc right up inside here. It helps prevent your positive lead from making contact with any part of this cell package, which is typically made of steel. And when I was harvesting this battery, it actually sparked on me because that one itty bitty little spot right there. See if the camera will be able to focus on that. You may be able to see there's a tiny little spot right there. All it takes is a pinhole. And any metal makes contact with that, you have a dead short on your cell. So it's important that when you're bare handling these cells, whether you're using them to power your flashlights, whether you're using them to power your mods for the vaping, for those who vape, it's very important that you pay close attention to this cell wrapping. And if you notice any spots on it, you definitely want to cover it up with tape. And really, this honestly is not a permanent fix. This is an interim repair. The proper way to repair this is to rewrap the cell with a new cell wrapping, and it's not terribly difficult to do. I'm going to have a video focusing on that here next, on how to rewrap cells. Here's another lithium-ion cell that is a good example of a cell that you would definitely want to reject and not use until you've rewrapped it. Yeah, this cell I would just skip my interim repair of using packaging tape and just go straight to rewrapping, because as you can see, there's a lot of frayed spots in this cell wrap, and these Panasonic lithium-ion cells they're notorious for it. You can see it's all tore up down here on the bottom side as well. So when you're loading and unloading these cells from your devices, whatever you have, you want to be careful with the cell wrap, because it serves a very important function. I mean, of course, it does make the cell look nice and pretty, but also it's there to insulate the negative of the cell. You can see there's several spots on the cell where negative is being exposed, and just think, negative, positive. That's how close they are to one another. Let's have a look here at some other examples. So these cells, you can see the wrapping is starting to kind of come up here. That's okay. The wrapping is still okay, but you have to keep in mind, if you're sliding this into something, it may catch on that and peel it back. And when that happens, that's when you need to rewrap your cell. So for example, on this cell, if you look around the top, and this is what I call the critical area, because you're getting very close to your positive terminal up here. You can see that the entire cell is fine. There's a little bit of nick right there, but it's not through. It's not all the way through. It's not exposing the metal. But I'm sure after some time, this cell will probably need to be rewrapped. This is a cell that I've used pretty heavily. And I'm going to be talking about these cells in a moment as well. I'll try if I remember to do so. So yeah, this is the negative side of the cell. This is, of course, where your negative contacts will be at. But again, as mentioned, the entire thing is actually negative, and this here is positive. Only its little piece of insulating material is what separates it. So do not. There's a few more things I'll mention about handling these things. Do not carry these cells loose in your pockets. I've seen online a lot of videos of these things exploding because of improper handling, due to shorting out in one's pocket. Now, these cells, most of these cells should theoretically not vent. What I mean to say is, they have what's called a protective CID, current interrupter device, inside here, that when, let's say, if the cell shorts out, if for any reason the internal temperature gets up and the internal pressure gets up, that should operate and cut power to the cell, but you can't rely on that as a surefire means of interrupting power from a dead short. So you always want to try to avoid shorting these things out as much as possible. And it also goes to when you're harvesting them from a laptop battery pack or power tool battery. Power tool batteries, you've really got to be careful, because those batteries are designed to put out a lot more current and also a lot more burst current. So you got to keep that in mind. So when you harvest these cells, it's important that whenever possible, look up a data sheet on the cell. Most of these cells, you'll have a model number on the side. Like, for example, this here is a Panasonic NCR18650B. And when you look up the data sheet, you'll typically see the rated capacity of the cell, the maximum charge voltage, which is typically 4.2 volts. For example, this is a 4.2 volt cell. You'll also see other things like the max discharge, and I want to mention that when you look at a lot of these specifications, you'll see what's called C ratings. Essentially, a C rating of a battery is a cell's capacity in milliamp hours instead of milliamps. For example, this is a 3400 milliamp hour cell, so think 3400 milliamp hours. Let's say if this cell is has a 2C discharge rate, that would be double the 3400 milliamp hour rating, or 3400 milliamps times 2. So typically with laptop batteries, this would be considered sort of in the laptop battery family. It's a lithium cobalt chemistry, I do think, and these things typically have a discharge rate of 2C, so only double the total capacity. So yeah, as mentioned, laptop battery cells, they're not designed for high current draw applications. They're more for low current draw applications that need a good high capacity. For example, would be, of course, laptops themselves, other electronic devices, some flashlights, things like that. And then you, of course, have your power tool batteries that have a discharge rating of a lot higher amount than these. So anyways, again, data sheets will tell you a lot of information about your cells. And if you can't find a data sheet, for example, a lot of times with these generic cells, it's kind of hard to find a data sheet. But sometimes, if you're lucky, it will tell you on the side the capacity in watt hours or milliamp hours. If this thing would focus, that would be nice. But so this cell says it's 7.4 watt hours, but a lot of these things don't tell you that. For example, this generic cell have a knockoff replacement laptop battery. This cell is rated for 1900 milliamp hours, and I think that the max discharge rate is like 2C, so pretty typical. But also, data sheets will tell you some interesting things about cells. For example, these LG Chem 18650s have a max charge voltage of 4.35 volts, not 4.2. Some of these cells like this offer that higher voltage charge to offer more capacity. Now this is actually a 3000 milliamp hour cell, and it's actually less than these Panasonics down here. These Panasonics are typically what you would consider the maximum an 18650 can hold. And I'm going to talk about that in a moment as well, if I remember to do it. So that's where the modification came in handy for this charger. So that way I could charge these or my regular 4.2 volt cells. And that's something you got to be very careful with, because you don't want to leave this thing set on 4.35 volts and then load in a 4.2 volt cell and overcharge it. At the least, doing so would damage the cell. You would lose capacity. At the worst, the cell could potentially fail catastrophically. So if you're wondering how these cells look when they fail or when they vent, it's not pretty. Now, it can be exciting to watch on YouTube, but you would definitely not want it to happen in your own house. Let's just say that. I definitely don't ever want to vent one of these things. I don't want to try venting one. So you may see the mod on these chargers. This involves hacking a hole in the bottom of the thing and accessing the switch, which can be switched on the fly. With the charger plugged in with no cells loaded, you can actually switch this thing from 4.2 to 4.35 volts. At least with this particular charger, you can do that. So, as mentioned, when you're like me and you have both 4.35 volt and 4.2 volt cells on hand, and you're interchangeably using them regularly, you've got to be careful. And that's why I have this little card made up. Anytime I switch this charger over to 4.35 volt mode, I set this on the charger to remind myself to switch it back when I'm done, or before I load in any 4.2 volt cells. So that's that. And also, you can see this camera right here. This is a Kodak ZI-10 Play Touch, which I have 18650 modded, as I call it. It involves removing the original battery pack, in this case, which was the Kodak KLIC 7004. This little mod will work on pretty much any camera device that runs on 3.7 volts. Essentially, I removed the original battery pack, which was a single cell battery, and I wired this in along with a 3 amp fuse. The fuse is there as a means of short circuit protection. Let's say if something inside the camera shorts, like a dead short, it would blow the fuse. Now I should mention that this 18650 mod that I have, you see there's two cells, okay? They're not in series, they're in parallel. I'm going to pull these out for a moment. And you can see what I'm talking about. You can see these two springs right here. They're facing the same direction. Now, some of these little holders that you can buy on eBay, you got to watch it because the way this thing was printed or molded, it instructs you to insert one cell this way and one cell this way. If you do that, you're going to have a dead short. And back in 2016, when I first bought these things, I was confused by that because the seller listing did not note whether it was parallel or series. And I loaded in one cell this way, and I loaded in one this way, and within 2 seconds of actually making contact, these were glowing orange. And I just backed the cell off real quickly and pulled it out. So, if you're like me and you work with these parallel holders, you gotta watch it. So what I do in that case, I load in one like this and load in one like this, make sure they're both facing the right direction. And again, this is positive, that's negative. Load them in like this and like that. And I should also mention that when you're running multiple cells in parallel in a device that has removable cells like this, you don't want to load in a fully charged cell along next to a completely dead cell. Now, there have been times to where I would put in 2 fresh cells and I noticed that my camera died rather quickly. It's because one cell wasn't making contact. I have actually done this and made them connect together. Not something I would always recommend, but I know for a fact that the current going from this cell to that cell or that cell to that cell was not terribly high, and they would balance themselves out. So yeah, that's a couple of things you gotta be careful with when you're running cells like this in parallel. So that's my 18650 mod camera. I have several cameras, including the one I'm filming with is 18650 modded. And the main reason why I do it is because I have so many of these cells on hand. It's much better than using the proprietary battery packs that come in these cameras because they have a low capacity. And of course I have lots of these cells. This camera here can run for about 9 hours on those cells right there. That's just an example. The CubeComp MTDX weather case camera number 1 can run for 11 hours continuous on 2 of those Panasonic cells. So that's out of the way. There's a few more things I'd like to talk about. So if you're like me and you harvest your cells from laptop batteries, with the exception of my Panasonic NCR 18650Bs, you may run across some bad cells or some crappy cells. You know, I've ran across both. I've ran across cells that were not holding the proper voltage, and I've ran across cells that were either in poor condition, they were neglected in the past, or just outright junk cells. So, for example, when you're harvesting from laptop batteries, one of the first things you want to do once you get the cells out is check their voltages and see what they are. Typically, if you find that your cells are at or above like 2.5 volts, you're generally going to be okay as far as possibly getting your rated capacity. But if your cells are below that, the cell has likely been damaged, and I wouldn't recommend using those cells. I have actually done this before. Back in 2016, I harvested some Carolina Blue Panasonic cells out of a Dell laptop battery. Most were holding at like 1.5 or 1.8 volts, and there was 2 that were holding at like 2.5 volts. And the ones that were holding at like 2.5 volts were working pretty reliably, but the rest of them, the capacity just really wasn't there. So while you may be able to rejuvenate those cells, I wouldn't recommend it. So here's an example. These 8 cells came out of my HP laptop's replacement battery pack that I bought last year. I noticed the battery was performing not so great pretty recently, so I took it apart and pulled the cells out. 2 of these cells were holding at only like 2 volts or so, and the rest were at like 3.6. Now I thought, okay, the remaining 6 were fine. Well, it turns out they weren't. And here's why. When I went to charge the cells, I noticed right away on the first charge up, they were getting mighty hot. So I should go ahead and mention now that when you're charging lithium-ion cells, it's normal for them to get slightly warm, but they shouldn't get hot. These cells, when they charge, you're supposed to charge them off of a constant current, constant voltage based supply, where the supply is at first current limited to the current that you specify on, like on your charger, for example, 1 amp. And once the battery gets up to close to 4.2 volts, the power supply will then go into voltage limiting mode, where it will limit current to keep the voltage at or below the specified maximum voltage. And that's exactly how this charger here works. And there's a look at the back of it, and you can see all the different kinds of cells that it can charge. So this one is designed to charge not only nickel. I'm sorry. It's designed not only to charge lithium-ion cells, but it can also charge nickel metal hydride and nickel cadmium cells too. So if you're looking for a do-it-all kind of battery charger, this one here is a pretty good candidate, I think. Now I mostly use this one for charging lithium-ion cells, and I have different chargers for my nickel metal hydride cells. But again, as I mentioned earlier in this video, it's paramount that you have a decent quality charger. Don't go buy something really cheap off of eBay, because a lot of the stuff you'll find on there, like for example the battery chargers that are really cheap, well, you may find some decent ones, but a lot of times you'll find some crap ones. This charger here, it tells you when you're charging with it, when you're discharging with it, it tells you lots of different things. Again, it tells you how much you're putting into the cell as far as capacity, how much current you're putting into the cells. It tells you that. It tells you a number of different things. And this battery charger can revive low voltage lithium-ion cells. So if you have very low voltage cells, this charger will this thing will do what it can to revive them. So if you decide you want to risk it and revive a cell that is showing very low voltage, the way this charger works and the way you should try to revive a low voltage cell is by starting the current very low. Don't try to force an amp to, like for example, if your battery is holding like 1.5 volts, don't try to force an amp into it. You start out really low, like 5, 10, 15, 20, 30 milliamps, maybe 50 milliamps. That's what this charger will do. Even if I specify a 1 amp charge on this thing and I put in a low voltage cell, it will cut things way down until the cell voltage gets up to about 3 volts, which is considered the safe minimum to charge a cell at full voltage. Or excuse me, full current. So yeah, again, it's why you should have a decent charger, and this charger here, it's been nothing but great for me. So, as I mentioned, I apologize. I'm going all over the place here. My videos are not scripted. So, when you're charging these cells and you're charging cells you're not familiar with, for example, you just harvested cells from a laptop battery and you're charging them for the first time, it's important to keep an eye on them to make sure that they're not getting too hot. Now, all these cells here, I trust. Matter of fact, I can put these on a charger and go to bed. I trust them. They've worked fine. But cells I'm not familiar with, absolutely not. Now, usually I don't charge cells and then go to bed, but sometimes if I'm really crunching on time, I need to have some cells charged up. Yeah, sometimes I'll put some on the charger and then go to bed. But yeah, don't do that unless you know your cells well. So back on the subject of laptop batteries, before you harvest a battery pack, it's important to look up the battery model number, and see if it's recalled. Because, for example, some packs from Dell and HP and Toshiba in recent years had to be recalled because the cells they contained were probably defective. There were a strain of cells from manufacturers Sanyo and Sony that when manufactured they may have gotten contaminated with small metal particles. And you wonder, okay, what does that mean? Well, essentially these cells, you have what's called a Swiss roll configuration. You have your different materials and between those you have a small separator. And if, let's say, if a metal particle gets in there and gets through the separator, it can cause a short. Either it be a minor short that just suddenly cause your cells to discharge at a random, or it could be a more serious short which could cause the cell to heat up and possibly catch fire and, explode. These cells, as mentioned, when they vent, they can be very violent and can cause some serious damage. So I'll say you should treat them with care and caution. Of course, I'm very familiar with handling these things. Many are not, so just want to mention that. Also, when you are charging your lithium-ion cells for the first time, it's a good idea to charge them up fully and let them sit for a while and see what the voltage of them falls to. It shouldn't fall much. It's particularly, like my cells, they typically rest at like 4.1 to 4.15 volts. But if you charge a cell up to 4.2 volts and come back a week later and it's at like 3.9 or something like that, it means the cell has a high discharge rate and you probably want to get rid of it. What happens is sometimes these cells, as they age, or if they're mistreated, overcharged, over-discharged, or what have you, sometimes what can happen is these little dendrites can form inside the cell and can cause the cell to have a very small short in it, enough to drain the cell down. And what can happen is it can get worse and worse and worse, eventually to a point where the cell could catastrophically fail. Especially when you're harvesting cells that you found to have a low voltage, like 2 volts on them or less. Although I don't recommend using batteries that had less than 2 volts because usually the capacity is kind of wrecked by that point. If you do decide to harvest cells of that voltage, again, it's important to, after you charge them up, let them sit for a week or more, and then check the voltage and see what they're sitting at. If it's noticeably lower, then you might want to get rid of the cells. It's just not worth risking it, in my opinion. It's because, like, for example, I work on computers, so I have lots of lithium-ion battery packs laying around everywhere in here from laptops. If these cells went bad tomorrow, I mean, as far as losing their capacity, getting to where they're not performing well, not holding a charge well, or whatever, I can, of course, crack open another laptop battery and I'll have replacement cells on hand. So with laptop batteries, a lot of times you'll find a battery pack that claims to be dead by the computer. It won't take a charge, but usually what happens is just 2 of these cells may go bad. And when you're harvesting these things, and if I hadn't mentioned already in the video, you want to check the voltage of the cells, of the groups, and see what they're sitting at. If they're sitting at below 2.5 volts, use caution with them. Matter of fact, if they're sitting below 2.5 volts, I really wouldn't recommend wasting your time with them because most likely by that point they've already lost some capacity. So yeah, you gotta watch out for that. So if they're sitting at 2.5 or more, I typically use them. But if they're sitting at or below that, I usually don't bother with them. I've harvested battery. I've cracked open laptop batteries that had all 6 cells or however many cells in good working order, and I have cracked open some that all the cells were sitting at next to no voltage. In that case, it was a total loss. And if you end up in that situation, don't waste your time trying to revive them, because laptop batteries are easy to come by. Matter of fact, I've harvested cells from both OEM packs from Dell, HP, Toshiba, and I've also harvested cells from generic replacement laptop battery packs before. So yeah, it's the opportunities are out there. So if you get a pack of bad cells, don't waste your time with the bad cells. That's my opinion. So anyways, to wrap this up, as mentioned, with these kinds of cells, you definitely use caution with them. It's a good idea to know basic circuits, basic electrical knowledge when you're handling these things. I mean, it's a good idea to know voltage, resistance, and current, Ohm's law, stuff like that. And of course, if you're not sure what that means, Look it up. There's lots of great articles and great videos on it. I'm not going to spend too much time talking about voltage, current, and in resistance here, but it's a good idea to know those basic things. And when you're harvesting these things, use care and caution. There's lots of videos on YouTube of people just outright beating these things with a hammer to get the cells out, and it makes me cringe when I see videos like that, because all it takes is for you to put all it takes is for this casing to get compromised, and you'd have a serious fire on your hands. I mean, just look up 18650 explosion, and you'll see some videos of these things exploding, and it's quite violent. So when you harvest them, be careful. When you handle them, be careful. Always take a close look at your cells. Make sure the wrapping is in good condition. If it's not, don't use the cell until it's repaired. And I mean by repair, if it's a very minor issue, you can tape it up for the time being. But again, rewrapping is something I recommend doing to maintain the things. Be careful with charging, discharging, and stuff like that, especially when you're working with cells like this that are not protected. You can actually buy protection circuits for these things, or you can actually purchase 18650s with a protection circuit built into them for your use and stuff like, whatever you wish. So yeah, I covered a pretty good bit of stuff here. Hopefully it's helpful. If you're new to lithium-ion 18650s, hopefully maybe you learned something today. Again, these are great for powering lots of different things, but you gotta be careful with them. You gotta use care and caution with them. Don't let your kids handle them and stuff like that, because of course these can pack a lot bigger punch than, let's say, an alkaline AA. So yeah, these are not your garden variety of, like, let's say, batteries, and this is why you don't typically find these on the shelf at Walmart. But there actually been a couple of times where I have seen these on the shelf at Walmart, but that's why you don't typically find these at like any corner store. So you definitely have to use care and caution when handling these. So again, I hope you found this video helpful and hope you enjoyed it. I know I'm all over the place with my videos sometimes because they're not scripted. I'm just thinking it off my mind. So anyways, hope you guys enjoyed this video. Thanks for watching. Well guys, that's it for this one. But it doesn't have to be. There's plenty more videos on the channel to check out. Also, if you liked the video, please click the like button. And if you absolutely hated it, there is the alternative button as well. But yeah, please subscribe to the channel. I definitely appreciate it. And remember to click the bell so that we get notified of all updates. Also, if you're interested in things aside from computers and technology, check out my second channel. It's CubeComp MTDX. Over there you'll find videos about weather, elevators, bicycling, and pretty much whatever else I figure out to upload. So yeah, anyways, hope you guys enjoyed this video, and thank you for your support.